In this section, we are learning about radian measure. Degrees and radians. Degrees and radians are the two most common means of measuring angles. Degrees are used to express directionality and angle size. If you stand facing directly north, you are facing the direction of 0 degrees, written as 0 with the degree symbol. If you turn yourself fully around so you end up facing north again, you have turned through 360 degrees. That is one revolution, or one circle, is 360 degrees. Radians, abbreviated RAD, are the metric unit measure of an angle. The radian measure may be defined as the ratio of an angle's intercepted arc to the length of the circle's radius. So here's a circle. This part of this angle that is on the circle is called the intercepted arc. So the radian measure for this angle is the ratio of this intercepted arc length divided by the radius of the circle. That gives us the radian measure of that angle. This symbol, theta, is often used to represent an angle in geometry. The intercepted arc of an entire circle, which is one revolution around the circle, is the circumference of the circle. So if the angle goes all the way around, then the intercepted arc is the circumference of the circle, or 2 pi r. Therefore, the radian measure of the entire circle would be the ratio of the intercepted arc, which is the circumference, over the radius of the circle. So we get 2 pi r over r, which then reduces to 2 pi radians. So the whole circle has radian measure 2 pi. Then, since the degree measure of an entire circle or one revolution is 360 degrees, it follows that 360 degrees equals 2 pi radians. Side note, why do we have to learn radians when we already have perfectly good degrees? This was taken from Purple Math. Because degrees, technically speaking, are not actually numbers, and we can only do math with numbers, this is somewhat similar to the difference between decimals and percentages. Yes, 83% has a clear meaning, but to do mathematical computations, you first must convert to the equivalent decimal form 0.83. Each of radians and degrees has its place. If you're describing directions to me, I'd really rather you said turn 60 degrees to the right when you pass the orange mailbox, rather than turn 1/3 pi radians at that point. However, if I need to find the area of a sector of a circle, I'd rather you gave me the numerical radian measure that I can plug directly into the formula, rather than the degree measure that I'd have to convert first. So, similar to how we convert percents to decimals when we want to do computation, we can convert degrees to radians for computation as well. You won't always be given angle measures in the form you'd prefer, so you'll need to be able to convert between radians and degrees. We're going to learn how to do that in just a moment. Since a full circle of 360 degrees is equivalent to 2 pi radians, here's a picture. Since we have this true relationship, it also follows that half of a circle, which is 180 degrees, will be equivalent to half of 2 pi radians, or pi radians. So 180 degrees is equivalent to pi radians. We will use the following conversion factors to convert between radians and degrees. Since 180 degrees is equivalent to pi radians, we have these conversion factors for converting between radians and degrees. How do we use them? Well, this one is specifically for going from degrees to radians. This one is for going from radians to degrees. In example 1, we want to change 360 degrees to radians. Since we're going from degrees to radians, we'll use the conversion factor for degrees to radians, pi radians to 180 degrees. We'll take the original measurement of 360 degrees and multiply by this conversion factor, pi radians, or 180 degrees. Notice that by setting this up this way, we can cancel the degree units here and be left with radians. So we'll have 360 times pi divided by 180 radians, which, reducing this, it comes out to 2 pi radians. Oh, of course, it's 360 degrees, so as we saw earlier, it should be 2 pi radians. Now we know how to find it by computation.